Hey, NR140, Kirsty here,
And Kunal, and we're the cool TAs.
and we're going to help you learn how to use R in RStudio.
We're going to be running descriptive stats on the BEF data, except in R instead of Excel or Jump. Just another way to do statistical analyses.
And a pretty cool way at that. All right, so our first step is to set our working directory, which is where you pull all your files from. So I'm just going to run that by hitting either Command Enter if you're in Mac or Control R if you're using a PC. And a way to check your working directory would be to use the getwd function. So all of that is working. We also install these packages.
So R has a bunch of base commands like loaded into the program already that help you find things like mean and median, for example. But there are some functions that R doesn't have already, so you can install packages and then load them if you want to access those functions.
So we've already done that. And so now, after loading those packages, we're going to upload our file, the BEF data, into Excel using this read XLSX function. And you have to assign it using a little caret and a dash sign to a name, and we chose BEF just to keep it simple. And you'll see it pops up in your environment over here, and you'll see it has 200 observations of 11 variables.
So now let's run the stats, and we'll start with the mean.
Mean's a pretty easy function, just the same thing, and we're going to do BEF, and then to subset the data.
Because we only want to take the BE data, we use the $sign, and then we can pick whatever column we want from our original Excel sheet. And so we want the BE data.
Exactly.
Perfect. And you'll see the answer or the value pop up in your console, and that is the same value that we got in Excel too.
Median is the same way. It's pretty easy. And we're just going to do BEF and subset it again.
So mode is a function that is a little bit harder because there's no mode function set in R. So we're going to write our own, which is a cool part of coding in R, that you can kind of tell it to do what you want.
So we use the function, which obviously makes sense. And we use curly brackets right here to write this function. And we found this function online, which is a pretty cool thing about R. Since it's all open source, a lot of the questions you'll come upon, people have already asked.
And people much smarter than us have already come up with those answers. And so this is like straight off the internet. We just copied the lines, and that's totally okay to do in R. And maybe one day you'll be able to answer people's questions yourself.
That's the dream. So here we go. Our function's been made, and you'll see it popped up here in our environment again under functions instead of data.
So now we can call that function the same way we did mean and median, except we made it ourselves. And so we do the same thing. We put our data in, and we subset. We want our BE column. And perfect. Our mode is 0 because the most common element in our data is 0. So let's keep going with the stats.
So standard deviation, again, is pretty simple, just SD.
Minimum, maximum, also simple, is just min.
And max. So you'll see I just typed those in and we got our answers as 0 and 0.88. Now we're going to find the skew.
And so skew and kurtosis are two functions that are not already loaded in R, so that's why we loaded the E1071 package that has those functions in it. And then, as you might remember, standard error of skew is the square root of 6 over n, which is the number of observations. And the square root function is already loaded in R, which is nice.
And we had 200
observations.
So I'm just going to save that as SES. Oops, again. There we go. So now we have that in our values section, and we're going to use kurtosis. Another function like Kunal said. that was part of that E1071.
Standard error of kurtosis, again, is square root of 24 over n, which in this case is 200 again. And the standard errors help us assess normality of the data, and we'll get to that later. So now we're going to try and we're going to assess for outliers. And so this is a little bit more involved because we want to make so now we're going to go into the outliers. You may notice Kirsty already typed in everything we need, so I'll just walk you through it. So this first line, upper Q, is going to get us the 75th percentile. The next line, lower Q, gets us the 25th percentile. IQR gets us the interquartile range. You could also do this by subtracting upper Q and lower Q. And then we're going to make an upper threshold and lower threshold for our outliers, and this is the equations you learned in class.
And to find the outlier, or the possible outliers, we're going to use this which function, and we use that to see if there's any numbers in the BE column that are lower than the lowest threshold or higher than the highest threshold. And you can see here it's empty, so that means there's no outliers, which means that we say no. And just a quick note that these hashtags mean that it, what is it called? What do they say?
It comments out.
Comments out.
And it's not running any functions.
Yeah, so even if you type a function in here, like say, as long as you use a hashtag, it turns it into just a comment.
So is our data normal? What do you think? Let's go back to our skew and kurtosis. Is the skew or kurtosis more than 2 times their standard error? Looks like the skew might be.
It does. That means not normal.
Congratulations, you've just done descriptive stats on the BE data.